Hello everyone, it's Malcolm Boudin here, another short take video where we're going to explain some quite complex network design this time, and some of the things that you need to talk with your colleagues about and think about in quite a lot of detail when you're designing a large scale carrier or service provider network. Okay, so you've typically got in a service provider network, you've got a mixture of, and I'm talking about MPLS here, so you might have like P nodes. I'll just draw 4 here, and let's say that they're fully meshed. And then this is like zoomed into a small part of a service provider network where you've then probably got a couple of PE nodes like this. They might be single homed or dual homed or whatever. And then another couple of PE, or one PE node here, might have a PE node here, and then you might have a PE node here that's redundantly connected like this. So you can see in this diagram, before we actually even start drawing in any customer sites, which might be like CE connected like this, or a CE that's dual homed, and I'll just draw them in like that because you can imagine that you might also have a CE based on the rest of the diagram where it's dual homed into there, and for whatever reason it might actually be dual homed into there as the second circuit, but this might be the primary and this might be the secondary. And I'll ask the question, do you have an understanding, or do you have a suggestion as to why you might go over this as the primary as opposed to this in this particular scenario? Think about it for 2 or 3 seconds. Well, the reason for this is that even though this picture looks like the CE here is miles, like hundreds of miles away or whatever, just from the picture, it might actually be closer. So if I change the ink colour, this link here might be closer to this pop than it is to this pop, which means the latency is likely to be less. However, that does depend on type of circuit as well. So if you have different types of circuits, like a least on net fibre, we spell fibre F-I-B-R-E in Scotland rather than F-I-B-E-R, just like data centre R-E instead of the ER, just in case you're wondering. This is the correct spelling. Anyway, on net fibre, whereas this PE might be via a wholesale circuit. Now, a wholesale circuit in the UK, if we take our focus off this diagram for a second, is like, if you imagine like a CE connects into a PE, and then that's on net, then if it's on net and this is the core, and then there's another site that's connected in the same way over here to a PE, the same sort of thing, then the traffic flow for these two sites to communicate with each other is going to go CE, PE, core. Once that's the core, other PE, and then CE. Okay, if we have a similar kind of setup and we have oops a daisy, let me just sort that out. If we have a wholesale circuit here, a wholesale circuit is where, we just rub these lines out. Wholesale circuit is where, if we want to get to this CE in the top right hand corner from this CE in the bottom left hand corner, you might still go into this PE, which is on net, or depending on the services that are available in the POP or exchange, you might go into a wholesale PE. Now, the wholesale PE has a link into its own core, which is a different service provider. So partner core, PC equals partner core, right? And partner core has some sort of link or NNI, network to network interconnect. And you can see here that in order to accommodate or facilitate for that traffic flow, if this CE wants to communicate with this CE over a wholesale circuit, it's going to come in here into a local PE. These might be in the same building, but the type of service, if it's a 1 gigabit per second fiber, might only be available on this PE, or this core network might be the only one that has capacity. So it comes in here over the core network, then over a partner NNI, and then over here. So with that in mind, if we go back to this diagram up the top, we have different requirements that are going to press this design. And if I go back to this colour here, and we say it's closer and the latency is better with this particular circuit, this blue one here that ends up on this PE. So this could be a 400 gigabit per second, and then this could be 2 times 100 gigabit per second with better latency. And that might be why when you strip it back and you go back to the first thing that we talked about, is like, why does this circuit actually perform better than it does to go via this particular circuit? Then that is one of the many reasons why. Okay, so when we are then planning the core network, we need to think about all these things when we're planning this whole core network in respect to latency, also packet loss, and when I say packet loss, we've got other things like contention ratio. Sometimes we've got 20 people trying to share one circuit in a 20-to-1 contention ratio, or 20 sites contending for the same bandwidth, which might be the 100 gig. But that's different to having like a dedicated 100 gig only for you. Okay, so that then has like a knock-on effect, packet loss. And after that, when we talk about packet loss, in the core network, we typically over provision the core network, but at the edge of the network, we want to ensure that we have a good QoS strategy on private networks anyway. And on if it's the internet, we still have a QoS strategy, but it's delivered in a different way. So we might have different path. It's called path conditioning. One of the vendors uses that, but I actually quite like the term path conditioning over the internet. Okay, so I probably went off on a bit of a tangent there. I wanted to speak about the complexity of network design, and to summarise, I suppose one of the things that you need to always keep in the back of your mind is things are not always what they seem. And what I mean by that is, when you see a network diagram, don't just assume that because you see a network diagram and you know this part over here looks far away from this node or further away than it is from here. That isn't always the case, and there's other factors that we need to consider when we are speccing up a core network and also when we're speccing up an edge network. So if we've got a router here which is a CE, we need to consider what type of link we need here, what type of link we need here, based on all of the stuff and a lot more that we talked about here. I'll maybe do some more of these videos, little whiteboarding session. Hope you enjoyed it, and we'll do more of these as over the next few weeks and months. Alright, cheers.